assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
This question says that a sample of CaCO3 solid is introduced into a sealed container of volume 0.654 liters and heated to 1000 Kelvin until equilibrium is reached. The Kp, or the equilibrium constant with respect to pressure for the reaction, is 3.9 times 10 to the negative 2 at this temperature, and it asks us to calculate the mass of CaO that is present in equilibrium. And so here's the reaction. CaCO3 decomposes to CaO and CO2 gas. It tells us the equilibrium constant Kp is equal to 3.9 times 10 to the negative 7. So let's write what this equilibrium constant means in terms of the partial pressures of the gases in this reaction. As you can see, there's only one gas in this reaction, CO2, so this will be a pretty simple equation. This will simply be the partial pressure of CO2. Since there's no term in front of CO2, there's no exponent here. And since there's no gas in the reactants, there's nothing in the denominator here. So 3.9 times 10 to the negative second, we can write atmospheres. So the standard here is the partial pressure of CO2, so that's simple enough. Now from this, we want to figure out how much CaO is produced. We need to figure out how many moles of CO2 produced if this is its partial pressure. We can do that using the ideal gas law, PV equals nRT. And we're going to solve for the number of moles n here. We know the pressure, 3.9 times 10 to the negative second atmospheres. The volume again in the question is 0.654 liters. We don't know n, that's what we're solving for. The ideal gas constant is 0.08206, and those units are liters times atmosphere divided by moles per Kelvin. Great. And then it's multiplied by the temperature, which the question tells us is 1000 Kelvin. Great. And our units cancel out. We divide both sides by atmospheres, divide both sides by liters. We have Kelvin on top and bottom here, and we have moles. It's in the denominator, but when we divide over to the other side to get n by itself, it goes to the numerator, so it's just moles. And if you did this, you would find that n equals 3.1 times 10 to the negative fourth moles. Great, so this is the number of moles of CO2, let's say moles of CO2 at equilibrium. Now we can just stoichiometry to figure out how many moles of CaO were produced and therefore what the mass of CaO is at equilibrium. So let's write this as 3.1 times 10 to the negative 4 moles CO2, and we'll do conversion between moles of CO2 and moles of CaO. From this, we can tell it's 1 to 1, so 1 mole CO2 is equal to 1 mole of CaO. And then we can multiply it by the molar mass, 1 mole of CaO equal to 56.08 grams of CaO. Units should cancel. We have moles of CO2 on top and bottom, moles of CaO on top and bottom. We're just left with grams of CaO, which is what we wanted. If you do this, you get an answer of 0.017 grams of CaO. And so based on only knowing the equilibrium constant of this reaction and the temperature pressure that it's occurring at, we can calculate that the amount of CaO equilibrium is 0.017 grams.